Hey guys, welcome back to my channel. Today we are going to learn how do we analyze data in Python using Pandas data frame. This is going to be a very exciting topic as you will be using this kind of exploratory data analysis for most of your data science tasks. But before we go there, if you are new to my channel, please hit that subscribe button and keep the notification on. Also, if you're liking my content, please hit that like button right away. Please also put your comments in the comment box that how am I doing with such videos. This will help me. This will motivate me to put more and more free content for you guys to learn Python and to become data literate. So before we start, I wanted to give you a highlight about what we are going to do in today's session. And there you go. So let's begin. I'd like to open Jupyter Notebook here. I'm going to create a new Python file, Python 3 file to be precise. And as I open up, it will give me a new tab in which it has opened up the file. It is untitled file, so let me rename the file. And I'll say this is Python for Beginners Part 4. And now we have the file ready. Today I have a dummy data which is called store sales data, and this data is available on public platform. So we are going to use this data, and I'm having this data in CSV file. So let me show you data quickly. If I open this folder, in this folder I have the data set. I'm quickly opening the file to give you a glimpse that how the data look like. If you see the data, it is having all this column called observation, distance, taxi, distance from market, distance from metro, store area, the number of items available, the status of parking, whether it's available, not available, open, no parking, etc. We have a coupon category. It's kind of some category of coupon or maybe customers. And then we have a daily customer count, like how many number of customers visiting to this store, and then we have a store sales data. So this data, we are going to read it in Python. So I'm closing this Excel sheet for now. And let me come back to the Jupyter Notebook. So before we go and analyze the data, let's import all the libraries that we needed to analyze the data. So for now, we need two libraries, NumPy and Pandas. So let me import both of them. So how do you do that? You call import pandas as PD. Now PD is an alias. You can use any alias, but PD is widely recognized. So I would highly recommend to use PD only for pandas. Let's import NumPy as well. So we'll call it as NumPy as NP. Let me slightly make the screen bigger. Okay. And as we hit Control or Alt and Enter, it's gonna import those libraries for this session so that I can use those libraries. Now the libraries are imported. So first thing we do is to import the data. Now our data is in CSV file, right? So let me create an object called data frame. Now data frame is nothing. You can create Pandas data frame. Remember from our last session that it's kind of a table where you store the data, right? So I'm calling this object called DF, which is nothing but a short form of data frame. You can put any object name there, and going to read pd.read_CSV. Now you can read multiple files, but right now since my file type is CSV, I'm using read_CSV method, and in bracket, I'm going to provide my file path. Now, since I know that my default path of this Python file is in the same folder where I'm storing my sales.csv file. So I need not to explicitly define the path. I can simply give the file name and an inverted comma. saying sales.csv, and that will suffice. In case if your data file is in some other path, you can just simply copy that path and paste it here under inverted comma, right? Let me execute this cell. Now you can call df and press Control and Enter, and this is how our data frame look like right now, right? It is having 940 rows and 10 columns. It gives you top 5 rows and bottom 5 rows along with all the columns, right? But if you want to specifically see the top sample of your data, like you want to see the top 5 rows, how will you see the top 5 rows? So you'll do like df is your data frame, and this is the method you'll use .head. When you do that, it will show you the top 5 rows, right? So it is having rows starting from 0 to 4, that is top 5 rows across all columns, right? That is your top head. Now check top sample is to see that whether your data is correctly imported or not. That's one thing. Second thing is how your data look like which or column you have. Just the way we open the Excel sheet and we seen the data, you can do similarly in Python by just simply importing the file, importing your data, and see how your data looks like. And if you want to see your bottom data, you can do df.tail, right? And when you do that with the bracket, you execute this cell, it will show you the bottom 5 entries. By default, it will take top 5 entries or bottom 5 entries, right? In case if you want to see the limited entries, say you want to see the top 3 entries only, you can give like maybe a 3. When you give 3 as an input, that means you wanted to see the top 3, right? And that will give you top 3. Similarly, in case if you wanted to see the bottom 3, you can do df.tail and maybe bottom 3, and that will give you only the bottom 3. Now, if you want to see what is the shape of your data, now how do we define shape of your data or shape of the data frame? That's number of rows by number of columns, and we'll call it df.shape. And shape is an attribute, it's not a method. So whenever you call shape, you need not to provide any kind of bracket there, but you simply call df.shape. Once we do that, it will give you 940 by 10. This is a tuple. If you don't know what is tuple, I'll put that video's link right over here, and you're gonna watch that video if you want to understand more about it. So this is 940 is the number of rows, records which is available, and 10 is the number of columns which we have in our data, right? If we want to know what is the size of the data, now when we refer to the size of data, please understand it by this way. The number of data points that we have in our data, so essentially it's number of columns multiplied by number of rows. So ideally, if you refer to the Excel sheet in your spreadsheet, what are the number of cells along with the details you have in those cells, right? So we count those number of cells. So when we do df.size, and again, it's an attribute, so you need not to provide brackets there. And let's execute this cell, and that is nothing but 940 multiplied by 10 here, and that will give us 9400. Now this will give us magnitude of data which we are operating right now. So it's total 9400 data points that we have. Let's see a few more things here. If you wanted to see what all different columns we have in the data set, we can type df.columns, right? And when we execute this, it will give us a series with all the column names. So the 10 columns which you have, it will give us the name of all the columns. So we have observation, distance, taxi, distance, market, and so on for all the 10 columns, right? Now, further, these are all exploratory things. So when you go by this method, you will come to know more about your data. You are not doing any kind of modeling here. You're just trying to understand what your data look like for now. If you wanted to see information about your data frame, we can do like df.info. Now this is a method, so we'll put brackets here and let's execute this cell. Information about the data frame. It says that it's a Pandas data frame. Yes, the df object is a Pandas data frame. It is having 940 entries ranging from 0 to 939. That's your index number. It is having total number of 10 columns, and these are all 10 columns which are listed. For each column, it will give us the non-null count. Now, here is the thing. In some of your columns, you will have values which are null values. Like there are no values present there. It's a completely blank cell there. So Pandas is going to count it as a null value, right? So it's going to give you how many total number of non-null values available there, right? So in observation, we have 940 non-null values, and it will also give you the D type. Now, D type is nothing but data type of that column. Remember, each column will have one data type. So we have integer 64. So basically, it's an integer column, right? And as you go to the next column, which is distance taxi, here we have total 927 non-null values, right? And it is having data type as float, right? So if we go to market, metro, store area, all those columns are listed here along with the null values and the data type. So we know that, okay, there are certain columns where you have null values present, while there are some columns where you do not have any kind of null values, right? And you also have integer data type of columns, you have float data type of columns, you have object data type within columns, right? And in bottom, you get like kind of summary. So your total 5 number of columns, which is of float data type. We have 3 number of columns, which is of integer data type. We have 2 number of columns, which is of object data type. Also, you'll get a visibility that what is the memory usage of this file in your system. So it currently captures around 73.6 plus KB of memory space in your system. So let's understand the distribution of data, like what is the mean, minimum value, maximum value, what is the average value, median value, all those kind of things. So what we do here is df.describe. Now describe is basically describing the data on 5-point summary. So when you say 5-point summary, it's minimum, maximum, and you have 25th percentile, 50th percentile, and 75th percentile value. Now, if you don't know what do you mean by percentile, I'm going to post a separate video on this 5-point summary, but it's what do you mean by 25th percentile is essentially that 25% of your data lies below this particular value. So that is your 25th percentile value. So when I say 75th percentile value, that means 75% of your data points are below this number. So when we do df.describe and execute this cell, it's going to give me all the 10 columns and the 5-point summary. Now, this is very cumbersome look. So what we are going to do is to put .t. And when I do .t, it's going to transpose this entire data frame. So my columns will become rows and rows will become columns for easy viewing or to recognize this data frame or to read this data frame with ease. When we do that, now we have same data, but organized in transposed form. So now we have 10 columns, and for each 10 columns, we have a number of count for the records available in that column. We have the mean value for that column. We have standard deviation of that column. We have minimum value of that column, maximum value of that column, and 25th percentile, 50th percentile, 75th percentile of the data, right? So we have, say, distance taxi. So we have total 927 counts. Now we know that mean distance taxi is 8223 units. We have standard deviation of 2556 unit. We have minimum value of 146 unit while maximum value of 20,662. So we have a good range of data available in distance taxi that we know. We also know that 50th percentile, which is nothing but your median value. That's 8230. We have 25th percentile value and we have 75th percentile value, right? Let's count the number of columns. We have 1, 2, 3, 4, 5, 6, 7, and 8. Oh, wait. We have 10 number of columns as we started, but here when we describe column, we only got 8 columns, right? Why so? Because by default, when you do describe, it will only pick up the numeric column. So remember, we have float and integer. Those are our numeric columns. So that will be 5 plus 3 total 8 number of columns. Only when you do describe, it will only give you those 8 columns, right? And it will not give you any object columns in description, right? If you want object column also in description, you can do something like this. Describe in bracket, you can say include is equal to all. When you do so, that means you are including all type of columns in your describe method. When we execute this, it's going to give you all type of column. Now we have 10 columns, including parking and coupon category, which is essentially your object column, and which will give you mean, standard deviation, minimum, maximum value. Since it's object category column, it's going to give you no number value. So it's going to give you this NaN number, right? Ideally, you should not include all. You should do numeric and object separately. So I usually prefer to remove this and just do it in for numeric columns only and separately object columns. So you do something like this, df.describe, and then you say include only the object. And I'm doing again the transpose way of looking the things. And when we execute this cell, I'm going to get only the object category columns, which is parking and coupon category. Going to get the total number of values in the column. What are the unique categories in the column? And you say that open parking is being repeated most frequently. So that's my top category with repetition over 376 times. So for 376 different records, you have open category as a parking, right? And then similarly, coupon category, you have a category B, which is top category. You have a total number of 3 different coupon categories available in your data. And category B is repeated 367 times. So I have that kind of visibility for object data frame as well, right? I wanted to show you one more thing here. When you do for numeric and you wanted to study more about percentile, right? So by default, it's gonna give you 25th percentile, 50th percentile, and 75th percentile. If you want to explicitly see the percentile values, specifically like 90th percentile or 99th percentile, right? You can provide this argument called percentiles, right? And you can provide a series, say that I also wanted to see 0.90th percentile and 0.99 percentile, right? So when you provide this input and execute cell, it's gonna give you along with 50th percentile, 90th percentile, and 99th percentile value as well, right? So that's additional input. Like if you want to see and dig more of your data in terms of distribution, you can do this as well, right? Let's move ahead and let's see a couple of more methods. So if you want to see the data type of any particular column, you can call maybe df and you can call dtypes, right? So when you execute this, now dtypes is again attribute, so you need not to provide kind of bracket, and when you execute this, you get for each of the column the data type. So if you don't want to do the information like df.info, you can just wanted to know the data types, you can do df.data types, and this will give you the data type for all the columns, right? Let's understand how do you call a particular column from a data frame. Now remember, this is how our data frame look like. Let me give you df.head, and this is how our data frame top sample look like. Now I just wanted to call this column, like I wanted to see only distance underscore taxi as my column. So how do you call column? So there are two ways you can do it. One way is you can call df and in square bracket. Now remember, how did you call a particular value from NumPy array, right? Or in our last video, we have also seen how did you call column from Pandas data frame. I'm just repeating again. So in a square bracket, you say that I wanted to see dist underscore taxi. It's gonna give you the values in that column, right? And that's your distance taxi column. Now, if you wanted to see two columns, how will you do it? So here, since you're providing series of columns, you did not wanted to see just one column, but you wanted to see two or more columns. So you are actually providing series of columns. So what you do essentially is you will do df, and in square bracket, you are going to call the columns, but you're not going to call columns one column, but you're going to call more than one column. So you will provide again a series in square bracket, and you say that give me this underscore taxi and also give me column dist underscore market, right? So you're providing square bracket within square bracket, and when you execute it, the cell, it's gonna give you both the columns, right? I hope this part is clear to you. Now, there is one more way you can call column. You can simply write df dot and just write the column name. So I'll say this underscore taxi, right? That's my column name. And when you execute this, it's going to give you the same way the column and its value. I personally prefer to write this because this is more convenient and readable. Also, most of the method you'll call with the help of dot and you'll write the method name. So sometimes the column names are very conflicting with the method name. You wanted to assure that this will be the right way to call the column. So it's up to you. You can call either of this method, but I'll personally prefer this method, right? So this is how we call the column. Let's call this particular column called df, and we are going to call this column as parking, right? So let's see what are different categories in the parking. So we say that parking, and by this way, I'm going to call this column, but this will give me all the values of parking across all the records, right? But I wanted to know what kind of like unique values are there across all 940 records, right? So how I'm going to do it, I can do with the help of unique method. When I do a unique method and execute it, I'll get like there are open, not provided, covered, and no parking. These are the 4 values which are repeated in parking column, right? So these are the 4 categories available under parking column, right? And if I wanted to count how many categories are available right now, I did it manually, but there is a method available. So let me do this. So I'll call again parking as column, and I'll say that n unique. When I do n unique, it will give me number of unique categories available in the data in that particular column. And sorry about this. Let me execute this n unique. So there are total number of 4 unique categories available, right? So that's unique and unique for you. Now let's call one more column here. Let's say distance metro, right? And this is the column we have. Now we know that there are 940 values or whatever values are there in this particular column. I wanted to know what is mean value in this column, right? I can do df.describe and I can go to df distance metro and I can find out mean value, which is nothing but 13,067, right? Or there is a other way of doing the thing. So I can call this column dot distance metro, and after that I'm saying that provide me mean value dot mean for this column, and if I execute this cell, it's going to give me the mean value, which is nothing but 13,067, which is exactly the same. Similarly, if I wanted to see maybe for distance metro again, if I wanted to see what is minimum value, I can apply dot min function, and that will give me the minimum value that is there in this distance metro column, which is 3227, right? Similarly, I can do maximum value from distance metro, and that's going to give me the maximum value in that column, right? I can also see standard deviation similarly, like distance metro, what is my standard deviation, right? STD, and that will give me the standard deviation in this column, right? So this is individually, you can pick up any column and try and get the mean and minimum and different type of like mathematical operations on that column, and you can get the value in Pandas as well. Now let's check, is there any kind of duplicate records in my data frame or any kind of null values that we see? Let's try and identify those kind of null values, and let's see how we can treat them or how we can remove those values. So let's see our data frame head first. Now remember, observation is nothing but it's kind of an index. Now I already have this index in my data frame by default in my Pandas data frame. So this is kind of a redundant column that I wanted to get rid of. And how do I get rid of this column? Is by doing df. So df is my data frame, and I'm calling drop this particular column. So I'm using dot drop, and within drop I'm providing name of my column, which is nothing but observation. That's the name of my column, which I wanted to drop. And in comma, how do Pandas know that I wanted to drop this column? So I'll provide this input called access. So when I put access is equal to 1, that means I'm going to delete the entire column. If I put access equal to 0, that means I'm going to drop rows, right? So right now I wanted to drop the columns. That's why I'm putting x is equal to 1. I'm also going to provide input called inplace is equal to true to retain those changes in my original data frame. Right? Execute this. Right now, if you see my df dot head and execute this, it is not having this column called observation, and this is how our data frame look like with 9 number of columns. Right? Why we drop this particular column? Because if there are duplicate records in the data, because of this column, you are not going to get the duplicate records because observation is a unique column, right? So if you have similar type of records which is repeating across all the columns, your observation, since it's a different number, it will not show you as a duplicate. So it's essential to remove this observation or unique identifier before you try and identify duplicate columns, right? So how do you check the duplicate records? Is with the help of df.duplicated. Since it's a method, we provide brackets, and let's execute this. So for each of the record, it will tell you whether that particular record is having duplicate or not. So it's give you Boolean value, true and false. Now this is not much of use to me, right? This is more of a Boolean value. So I know that Boolean value is 0 and 1 in the background. So false is a 0 and true is 1. So when I do dot sum, it's going to sum up all this value and it will essentially give me number of duplicated records I have in the data. Let me execute this. So I know that total 8 number of records are there which are duplicate records. Now I don't want those duplicate records in my data frame. So what I'm essentially going to do is to drop this duplicate records. And how I'm going to drop this duplicate records? It's with the help of df.drop_duplicates. And when I do df.drop duplicates, I'm also going to provide inplace is equal to true, right? So when I do that, it's gonna drop the duplicates and retain the changes in df, right? Now, if I check my shape of the df, right? So now I have 932 rows and 9 columns. So remember, we have dropped 1 column and 8 records. So my shape of the data frame has changed now. Let's check the null values in the column. We have seen that we have a couple of null values across different columns. So how do we check null value? With the help of is null. When you do is null, right, it will check column by column, like null values in that particular column. It's going to give you Boolean comparison, whether it's there or not. So it will give you false and true. Now this is not much of a use. So when I do dot sum, it's going to sum up all the true values column wise, and it's going to give you like distance taxi. I have 13 null values. For distance market, I have 13 null values and so on. Like if I wanted to know what is the total null values in the entire data frame, I can again put dot sum here. And once I do that, it will again gonna sum up all these values and gonna give me total number of null values in my data frame. And that's total 50, right? And I don't want all this null value for now. And I want to remove all this null values. So I can drop this null value as well. So how I drop this null value, I can do this df.drop NA. When I do df.drop NA, essentially it will delete all the rows wherever it finds any kind of null value in any of the column, right? So it's gonna delete all those rows, and I'm also going to give you in place is equal to true, right? And when we execute this, it has successfully removed all the null values. And let's check the shape now, df.shape, and that's now we have 898 records, 9 columns. Okay, let's see a few more things. So how you call a particular kind of column? As I said, you can also call with the help of ilog method. So in ilog method, ilog is nothing but index location. So when you provide index location, you are providing basically in square bracket the location of in terms of rows and columns. What do you want? So I'm saying that I want first row and I also wanted to see the first column. And let me execute this cell. It's going to give me this value. So what is there in my first row and first column? So let me show it to you. Are we correct or not? Let me pull out the top sample. And you see that in my first row, right? This is my first row and this is my first column. Now Python, as you remember, the index starts from 0. So this is 0 and 1. This is my first row and this is my first column. This is distance taxi is my 0th column. Distance market is my first column. So it's going to give me 8186 as a value. Now, what if I want this block, particular block, which includes distance taxi and distance market, along with 0th row and first row? So here, instead of df log, and in my row input, I'm going to provide, I want 0th row all the way to second row. Now, second is excluded, right? So it's going to give me 0th and first row. Similarly, I also want 0th column up to second column. So second is excluded. So it's going to give me 0th and first column. When I execute this, it's going to give me this little square block here. Now, if you want particular column, say distance market, I know it's a first column in my data frame. So I can use df.ilog and in square bracket, when I do this colon, that means I want all the rows and I'm saying, give me the first column. Right? When I execute this, it's going to give me the first column. If I want like first 3 columns, I can write like 0 to 3. That's going to give me first 3 columns. When I execute this, it's going to give me distance taxi, distance market, and distance metro, 3 columns across all the rows. So this is how we can use ilog method also to call a particular record, columns, or rows from the data frame, right? Let's see a few more things and how do we filter out the data, right? So now I also wanted to see a data frame where my distance taxi is more than maybe 9,000 units, right? So how do I do that? So let me call df and I say distance dist taxi. And I wanted to see that this taxi has to be greater than 9,000 unit. When I do and execute this cell, it's going to give me like for each of the record, whether this particular condition is true or false. But this is not useful. I wanted to filter those records, right? So I can use this condition. So let me copy this condition and let me say that from my df, and this is how I'm going to pull the record, right? Within the square bracket. And I'm putting that condition. I'm saying that, let me show you again. So df in square bracket, I'm putting that condition. I'm saying that pull out records from my data frame, which only matches this condition, right? And when I execute this, it's going to give me the records like 342 rows, right? Which only satisfy this condition where my distance taxi is more than 9,000, right? Now, what if I have multiple condition, right? Like I also wanted to filter the records which are having distance market more than 10,000, right? So I can do that. I can very well do that. Let me type this df. So this was my first condition, right? df where my distance taxi is greater than 9,000. Along with that, I can put the operator called AND, right? This is a AND. And I say that include also the distance metro, which is more than 10,000, right? So I'm putting one more condition here separated by AND, and I'm putting both the condition in a bracket to separate it. And once I execute this, it's gonna give me 342 records, right? Where distance metro is greater than 10,000 and also distance taxi is more than 9,000, right? Now, if I wanted to see that my distance metro is more than 20,000, I can do that. I can change my condition and let's execute this. Once I do that, I know that only there are 5 records where my distance metro is more than 20,000 and my distance taxi is also more than 9,000, right? Now, if you wanted to see like, this is an AND condition, right? You also wanted to see that either or type of condition. That means my distance taxi has to be more than 9,000 or my distance metro can be more than 20,000. So it's not an AND condition, but you are going for OR condition. This is the sign of OR condition. Now, in your keyboard, just above the enter or just above the backslash, you have the sign, which is the OR sign, right? So when you put this sign and execute this cell, it's going to give you like 342 records, which is having either of these two conditions satisfied, right? So this is how you can filter out particular data from your existing data frame. This is super critical because this type of conditions you are going to use very frequently when you do your exploratory analysis, right? Now, let's see a few more things here. You can also do group by. When you use group by, you are essentially trying to pivot a particular column and try and see other columns, how they behave against this particular column. So it's more of a pivot table, a pivot view in your Excel sheet, right? So you can use df.groupby, right? So in group by, you are seeing a name of columns. So let's say I wanted to see parking, right? When you do df.groupby parking, that means Python or Pandas is going to create a group by object. So it's not going to give you any kind of output, but it shows you that Pandas has created a group by object, unless you further instruct that what you're going to see it, right? So I'm saying that group by parking. Also, along with the parking, I wanted to see what is my store sales. So let me type store underscore sales. So this is the column which I'm calling from this object. I'm including this column. And I also wanted to see the mean sales of all stores across this group object. So parking category wise. Let me execute this for you. So once I do that, it will give me that for parking, for covered parking, no parking, not provided, open. These are 4 different type of parking objects. Now, all the records which is having covered parking, this is their mean store sales, which is nothing but 71,166. If I do no parking, that's 56,000. So I know that wherever you have a covered parking, you have one of the highest sales among the other categories. Whenever you have no parking, you are having the least sales. So those kind of insights you can derive when you do group by. Now, you can call multiple columns instead of just store sales. So let me do that. Let me do group by again, parking, right? And here I'm saying that I want series of columns. So I'm not just providing one column, so 2 columns. And that's why I'm going bracket within the bracket. And I'm saying give me store sales and also give me maybe, let me see. Let me give me daily customer count, right? So I'll say give me also daily underscore customer score count, right? And give me the mean values for it, right? And once I execute this, it's going to give me this kind of table. So I have a covered, no parking, no provided, not provided, and open. I know that store sales is 71,166 under covered parking, and which is highest. And where my daily customer count, although it's low, but it's going to give me more sales. Similarly, when I have open parking, my number of customer counts is higher, but my sales is not to that mark like what I have in covered parking. So this type of group by object, you can see maybe this is mean value. If you wanted to see like minimum sales, you can do that. You can provide mean and you can see the minimum value. So let's do standard deviation here. And this is how you do standard deviation also, if you wanted to understand standard deviation, right? And since it's a long number after decimal place, if you want to round it off that number, you can use .round as method and provide maybe a 2-digit. So 2 decimal place rounding, you can do that. In case you want rounding up to 1 decimal place, you can provide 1 as an input and do this way. So to effectively view and read the data, right? So this is a group by method for you. Similarly, there is one more important method available, which is called pivot table. So you can pivot your data. So pivot table is super critical, and that will help you to dissect your data in multiple dimensions. So let me give you input. So as you do that pivot table, it asks you to provide index. So index is nothing but what do I want it to see as rows. So I'm saying that on index, I want it to see maybe, let's say parking again. And I want it to see in columns, maybe category. So the coupon category, right? So I'll write coupon.category. Now remember, both this column are object column. So we also need to provide what values we wanted to see within the table. So let's say values for now, I wanted to see is store underscore sales, and execute this. It's going to give me parking here, the category, and the category of coupon category of the stores. And it will also give me in between these two categories how the store sales are appearing too. And if you want to see the rounded data, you can do something like this, round, and that's going to give you the rounded number. Now, as we can see that in covered parking, we're seeing that we're getting the maximum sales, but let's see how it spans out when we talk about the coupon category. So within coupon category, when you have a category store B, you get the maximum sales when you have a covered parking, right? Now we know that wherever parking is not provided, your sales was the lowest. But when you have a category A stores, you still get the higher sales compared to whenever you have no parking, right? So those kind of insights you can derive out of this pivot table. Now by default, these are all mean sales, right? Now, if you just wanted to see what are the number of stores available in each of these different categories, you can simply copy this data and put it here. And here you can provide argument for aggregate function. So aggregate function by default, it takes the mean store sales, but you wanted to do something like maybe count, right? So you can do like count here. And as you execute this cell, you're going to get the number of stores in each of the category present in your data. So we see that the maximum number of stores are of category B, right? And having open parking. So we have 149 stores which are of category B and having open parking. And there are only 49 stores or maybe 40 stores available here which are of category C and having no parking, right? And if you wanted to see like the total of each rows and each column, you can provide inputs such as margins is equal to true. When you do margins is equal to true and execute this, it's going to total up. So we know that now total 181 stores where we have covered parking, 141 stores where we have no parking, and in all we have total 898 stores. Similarly, category B we have total 348 stores and so on. This is how we can do the analysis with the help of pivot table. I hope this video is useful to you. We have seen a lot of methods which is available in Panda, which enable you to do the exploratory analysis. Please use this methods and please practice it so that you internalize all these methods and you do exploratory analysis with ease with the help of Pandas. I'm going to load this Python file as well as the data file in the video in the description right below. You can access these files from there. Please like, share and subscribe my channel. Thanks for watching. Bye-bye.